going, that's going. So we do ellipses today. An ellipse, like the others, right? Circle was the set of all points equidistant from a point. Parabola was the set of all points equidistant from a point and a line. And now we've got an ellipse, which is a little similar but different. An ellipse is the set of all points, the sum of whose distances from two fixed points is constant, right? So the two fixed points, right, are called, each is called a focus, and together the plural of it is foci, F-O-C-I. Okay. So notice they've drawn one point on this ellipse, and they've shown the distance, right? This D1, that's the distance to one focus. D2 is the distance to the other. If you add those up, D1 plus D2, that's the same for every point on the ellipse. Now, the foci lie along, I mean, we know that an ellipse is an oval, right? It's like a circle is longer in one direction than the other. The foci are on the long direction, what's called the major axis. And the center would be halfway across the ellipse. And if you went in the perpendicular direction, which is going to be shorter, it has to be shorter, that's the minor axis. So major axis is the long length of the ellipse. The minor axis is the short length of the ellipse. They both go through the center. The foci have to be along that major axis. For ellipse, there's one other thing that's on this graph you got to look at. The ellipse has two vertices, right? The vertices are where the major axis intersects with the ellipse. Vertex and vertex. So parabola had one vertex and one focus. Ellipse has two vertices and two foci. Again, don't copy every little mark on the page. You got it in the book. Right? Same thing here. I mean, let's not copy every little thing on here. Be here all day. Just like a parabola, we had standard forms of equations for an ellipse, right? And they look kind of, there's a lot of things that are in common, right? You definitely see x minus h squared and y minus k squared, right? This time they're both squared. This time the hk is not a vertex, it's the center, right? The center of an ellipse has the coordinates hk. And you can see there's two versions of it because there's got to be one for when it's longer in the x direction, and there's got to be another for when it's longer in the y direction. So major axis horizontal, major axis vertical. And what's the only difference between those two? Yeah, I mean, a squared, b squared, right? Here, the a squared is underneath the x, and here, the a squared is underneath the y. Now remember, up here, it tells us that the length of the major axis is 2a, right? And the length of the minor axis is 2b, right? So which is bigger, A or B? The A's got to be bigger than the B. That's half the distance of the major axis, and the B is half the distance of the minor axis. So A is bigger than B. So when you're looking at standard forms of ellipses, whichever has the bigger denominator, that's the A. That's going to tell you whether it's horizontal or vertical. So you're just looking to see which has a bigger denominator. And there is one important piece of information here, which is that there is like a Pythagorean theorem looking kind of thing, which we don't always write it like that, but you could look at it like this. A squared equals B squared plus C squared. I should have had a picture here, but here's the center. That's A. This is B. So A is half of the major axis, B is half of the minor axis, C is the distance from the center to a focus. So which is necessarily the biggest of those three? A has to be bigger, right? A has to be bigger than B, right? And it has to be bigger than C because C is the distance to the focus, and focus inside the ellipse, right? A takes you all the way to the side, C just takes you part of the way. So when you have this Pythagorean theorem looking kind of thing, it's not Pythagorean theorem, right? Pythagorean theorem says C squared equals A squared plus B squared, because in a right triangle, C is always the biggest. But in an ellipse, A is the biggest. That's why it's A squared equals B squared plus C squared. Okay, and then like they did with the parabola, they gave us versions of these standard equations if the center is the origin, meaning you're not subtracting anything from x and y, then it looks like this. Now, one thing that the ellipse has in common with the circle is that both x and y are squared. A parabola is the only one of the conics, or conic sections, which only has one variable squared. What that means is, if we have to put one of these in standard form, we have to complete the square twice. Parabola is the only one you can just do it once. All the others, you got to do it twice. So here's the diagrams of the two, right? If the major axis is horizontal, right, you can see the 2A takes you from side to side. And we will get problems that says the length of the major axis is, right? And what are they trying to tell you? The value of A, right? You could if you know what the length of the major axis, you know the A, right? If you know the length of the minor axis, you know the B. Oh, another thing to look for, which is the right-hand side is always 1. Okay, if you don't have a 1 on the right-hand side, you got to do something to make a 1 on the right-hand side. Okay, so like I did last time, I'm going to go through even number homework problems that are similar to the one you're going to do. Exactly similar, right? With the same directions, so it shouldn't be confusing at all. If you get confused, watch the video, right? Watch how we did it. You can just substitute one for one with what we did, right? So this one, it says, find the standard form of the ellipse with the given characteristics. The center is at the origin. Okay, now they didn't actually ask us to graph it. They just said, you know, the center is at the origin, find the equation. So let me, but it helps to sketch a graph. Let's see, the vertices are at 0, plus or minus 8, right? So that's 0, 8, and 0, negative 8, right? Here's 0, 8, and here's 0, negative 8. Right? Those are the vertices. So we know that this thing is going to look something like that, right? Remember that the vertices are intersecting with the major axis, so this is definitely vertical. So which form of the equation are we going to use? We're going to use x minus h squared over a squared, right? No, sorry, that was wrong. Edit, undo, edit. Over b squared plus y minus k squared over a squared equals 1. Now, they've already said the center is 0, 0. So we know where the H and the K are, 0, 0. We just have to figure out the A and the B. We can tell this, what is that distance? Half of the major axis is what? A, right? So A equals 8. We know that one. And we know that the foci are at 0 plus or minus 4. So that means there's a focus there and there's a focus there. Right? What does that distance represent? It's 4. We've already defined the A. Is that the B or the C? It's the C, right? So by giving us the information that they did, they gave us the A and the C. But we don't need the C. We need the A and the B. So we've got to figure out the B. And how are we going to do that? With that Pythagorean theorem looking kind of thing, right? So you're going to go to the A squared equals B squared plus C squared. And you can fill in for what you know, right? A is 8, C is 4. 8 squared equals B squared plus 4 squared. So 64 minus 16 equals B squared. B squared equals 48. Okay, now, do we need to solve for B? Do we need to take the square root? Where are we going to plug it in? Right there. It's squared. We don't really need the B. All we need is B squared, and we've got it. So just fill in what you've got. X squared over 48 plus Y squared over 64 equals 1. Done. Okay, and this one they're telling us, it's another one where we're being told right up front that the center is at the origin. This time they're giving us the foci and they're giving us the length of the major axis. Okay, so let's see. I can plot the foci, right? Plus or minus 2, comma 0. So that means 2, negative 2 are the foci. Is this thing going to be horizontal or vertical? If the foci are here. Remember, go ahead. Yeah, it's horizontal, right? Because the foci lie along the major axis. So major axis definitely is horizontal. So we need this form. X minus h squared over a squared plus y minus k squared over b squared equals 1. Okay, we know the hk is 0, 0, so we'll be able to substitute that. Which of those 3 letters did they just tell us by telling us where the foci are? What does this distance represent? The center to the focus is C. We know that the C is 2, right? But we need to know the A and the B, right? How can we use this piece of information to know either the A or the B? The major axis is 2A. Remember that? From side to side, look at this one here, right? It's A to the left, A to the right, so the whole thing is 2A. So when they're telling us the length is 10, what's the value of A? 5, right? So this is telling you that 2A equals 10, A equals 5, right? Okay, so now we know the A and the C. How can we find the B? Since that's what we need to plug in. A squared equals B squared plus C squared, right? So we have A squared equals B squared plus C squared. 25 equals B squared plus 4. So B squared equals 21. So now we can fill in for everything, right? X squared over 25 plus y squared over 21 equals 1. Unfortunately, when we get to the next one, which is hyperbolas, right? There, they have the same kind of equation, but it is c squared equals a squared plus b squared. It's exactly like the Pythagorean theorem. This is the one that's different. Okay, now we don't necessarily know that the center is at the origin, but it's still the same kind of problem, right? Where you're going to have to take this piece of information and see if you can find the standard equation. And as always, you probably need to graph them first. I mean, if you can make sense of it without graphing, you're better than me. So let's see, the vertices are at 3, 0, and 3, 10. Right? 3, 0, and 3, 10. Right, so there's one vertice, and there's the other vertice. That's 10. Okay, if the vertices are there, where would we look to find the center? Exactly halfway between them, right? So what is exactly halfway between these two? 0, 3 and 0, 10. Halfway in between would be 0, 0, 5, right? The center, HK, right? HK is 3, 5. It's halfway in between. Okay, knowing that, what is A? Right? A is this distance here. A is 5. Right? And they also told us that the minor axis length is 4. So what are they telling you by telling you that? B is 2. Right? 2B is 4. So B is 2. Now, do we need the vertical or horizontal version of the standard form? It's vertical, right? They said the vertices are along the major axis, so we need this one. X minus h squared over b squared plus y minus k squared over a squared equals 1. And we know everything. We know the HK, we know the A, we know the B. So just fill it in, right? The HK is 3, 5, so that's X minus 3 squared over B squared, which is 4, plus Y minus 5 squared over A squared. A is 5, so A squared is 25 equals 1. If the minor axis has a length of 4, right? The minor axis has a length of 4, that's B plus B, right? 2B is 4, so B is 2. What's that? Oh, yeah. I'm not good about that sometimes. My B's look like 6s, and my sometimes my 4s aren't very good. Okay. So try another one. And this is another one. Again, you're going to have one just like it. We know where the foci are, and we know what's the length of the major axis. Okay, before we do anything, if the major axis is 16, what is A? 8. Right, that's 2A. So A equals 8. So we got that one before we start. If I plot these 2 points, right, that would be 0, 0, and 0, 8. 0, 0, right, these are foci. Okay, so where's the center? Halfway in between the foci, right? The center is halfway in between the foci. It's halfway in between the vertices. So where will it be? 0, 4, right? So the center, HK, is 0, 4. Okay, so what distance did they just tell us then? Now that we know that, what does that distance represent? Nope. A is the distance from the center to the vertex. This is the distance from the center to the focus. C. C is the distance from the center to the focus, right? So C equals 4. Okay. Now, we don't need C. We need B. How am I going to find B? A squared equals B squared plus C squared, right? We know what the A is. We know what the C is. Find the B. Right, A squared equals B squared plus C squared. 64 equals B squared plus 4 squared is 16. So B squared equals 48. Which these numbers do tend to repeat themselves quite a bit. Because they're not trying to use odd numbers. Most of these things involve squares, right? Perfect squares. And then when you do a subtraction of perfect squares, you get some common numbers repeat themselves, like 48 comes up a lot. Okay, now which version of of the standard form do we need? Is it vertical or is it horizontal? It's vertical. So we need to fill in this form, right? X minus h squared over b squared plus y minus k squared over a squared equals 1. And we know everything we need to plug into that, right? We know the center, we know the a squared, and we know the b squared. So the center is 0, 4. So the first term will be x squared divided by, we just said b squared is 48, plus y minus 4. It's too sloppy. That's still pretty sloppy, but a is 8, so that's 64. I don't like that at all. Okay. So I think these are the ones, they don't actually ask you to graph it. All they ask you to do is, come up with the standard form of the equation, but you probably find it useful to sketch a little bit so you can tell what's A, what's B, and what's C. I think the next one, it involves a graph. So it says, find the center, the vertices, the foci, and then it adds something in there, which we will go back to later. We're not going to do it right away. In the end, it's an easy thing to add. Okay. So find the center, vertices, and foci. Okay, well, looking at this standard form of the equation, what's the center? Do you see anything being subtracted from x and y? It's the origin, right? So the center is here. Is this thing going to be horizontal or vertical? How do you tell? Remember, which has the bigger denominator, the x or the y? The x does, so it's horizontal. I mean, you don't even have to hardly think of it like that. Just think right now, right? You're going to go the square root of that distance in the x direction from the center, right? So the square root of 64 is 8, right? So you're going to go left 8, and you're going to go right 8. And in the y direction, you're going to go the square root of 28, right? So the square root of 28 is, just to approximate, right? It's more than 5 and it's less than 6. How about we'll make it about 5.2 or something like that. So in the other direction, 2, 3, 4, 5, maybe it's here and here. I mean, with just those 4 points, you can sketch your ellipse. And then looking at the ellipse, is it horizontal or vertical? Is it longer in the x direction or the y direction? I mean, it's longer horizontally. I mean, but yeah, you ought to be able to look at that and say, okay, the bigger denominator is 64. That means 64 is a squared, right? And the 28, that's the b squared. Okay, so we have the center, the vertices. How are we going to find the foci? Remember, you got to have the c, right? We don't know c. We know a and b. Now we have to calculate the c. So a squared equals b squared plus c squared. We have 64 equals 28 plus c squared. 64 minus 28 is 36. So c equals 6. So along the major axis, we've got to go 6, 1, 2, 3, 4, 5, 6 to find one focus, and 1, 2, 3, 4, 5, 6, and the other. So if you're asked for all those things, I mean, you've sketched them on a graph, now you should label them. So this one is negative 8, 0. This one is negative 6, 0. This one is 0, 0. This one is 6, 0. This is 8, 0. Right, this is not centered at the origin, but it is in the standard form. So you don't have to do a lot of, you don't have to complete the square bottom line. It's already in the standard form, right? So what is the center of this ellipse? Negative 3, 2, right? So the HK is negative 3, 2. So we can put that out. We're negative 3, positive 2. There's the center. Is this one going to be vertical or horizontal? Because which has a bigger denominator? Y, right? Then y is the vertical coordinate. So definitely this is our a squared. So a equals 4. And this is our b squared. So let's see. We're going to go in a vertical direction. We're going to go up 4 and down 4. Up 4, down 4. In the horizontal direction, we're going to go the square root of 12, which again, it's in between 3 and 4, right? 3 squared is 9, 4 squared is 16. So let's call it 3.5. That's our estimate. B equals 3.5. You know, for our purposes, we just have to sketch the ellipse. So, you know, whether or not it should have been 3.4 or 3.6 won't make a big difference. Right? So those are the sides of the ellipse, right? This is in the long direction, this is in the short direction. Connect them up. Right? And then the last thing we've got to put on there, the foci. And what do we need to place the foci in the correct place? C. Again, so we got to go back to the a squared. That was bad. a squared equals b squared plus c squared. 16 equals 12 plus c squared. C squared equals 4, so c equals 2. So from the center, in the major axis direction, which we just said is vertical, go up 2 and down 2. Up 2, down 2. Those are the foci. So now I'm going to label all those points. This was -3, +6. This was -3, +4. This was -3, 2. -3, 0. And -3, -2. Right, which that leaves us one more kind of problem that we didn't do, where you got to complete the square. So let's do that. You'll get 1. So remember, when you have an ellipse, you know, you could be completing the square twice, right? I mean, you're definitely going to have an x squared and a y squared. The thing you don't know is whether or not, if you have to complete the square, it's because not only is there an x squared, but there's an x to the first. Then you got to complete the square. Not only is there a y squared, but there's a y to the first. So we have to complete the square twice. So if you do it twice, I would do it like this, right? Get your x terms together, 3x squared plus 18x plus y squared minus 2y, and then move the 8 to the other side. Add 8 to both sides. Now remember, when we complete the square, whenever you complete the square, you need to have a 1 as the coefficient of the squared term. And in this case, you don't have it on the x squared. What do you do for a first step? You factor 3 from both terms, right? So this becomes 3 times x squared plus 6x, okay, plus y squared minus 2y equals 8. Right? I've put in the parentheses. I factored out the 3. I've left a space now inside to complete the square. And I've organized the y's with a space to complete the square. Okay, what am I going to add into the third position here to complete the square? 9, right? Because half of 6 is 3. 3 squared is 9. Right? What do I have to add to the other side to balance the fact that I just put a plus 9 there? It's 3 times 9, 27, right? So you got to say that is plus 27 on this side. Okay, what am I going to add to the third position for y to complete the square? 1. Half of -2 squared is 1. And what do I add to the other side to balance the fact that I just did that? Plus 1, right? We're adding to both sides of the equation, so it's the same thing. It's not like the ones we did as a practice a couple days ago where we subtracted on the same side. So we add 1. Okay, so now this is 3 times x plus 3 squared plus y minus 1 squared equals 36. Right? Is that standard form? What do you need to have on the right-hand side if it's standard form? A 1, right? If it's not a 1, you got to divide by that number, right? You don't subtract 35. Because if you subtract 35 on this side, you got to subtract it from this side, and that wouldn't be right, right? You can't have a constant term on this side. If you divide every term by 36, right, then we've some simplifying we can do. Right, in the first term, 3 goes into 36, 12. So that's x plus 3 squared over 12 plus y minus 1 squared over 36 equals 1. That's the standard form. Okay, now we can do what we did on the last slide. Is this vertical or horizontal? Bigger denominator under the y, vertical. Vertical, right? Bigger denominator is what determines it. What is the center? -3, 1. -3, +1 is the center. This is the a squared, right? So a equals 6. So you go up 6, 1, 2, 3, 4, 5, 6. Down 6, 1, 2, 3, 4, 5, 6. Right? The b is, again, 12. We'll approximate. If that's b squared, then b is approximately 3.5. So we'll go right 3.5 and left 3.5. And that should be enough to sketch the outline of the ellipse. Right? So we'll go something like that. And then the last thing we got to add to it is the foci, right? So the foci, we have to do our a squared equals b squared plus c squared. 36 equals 12 plus c squared. So c squared equals 24, and c equals the square root of 24, which is going to be about 4.9, right? Because 5 squared is 25, so let's say call it about 4.9. So we're going to go almost 5 up, 4, 5, about right there, and almost 5 down, about right there. And with that, we can label all these things, right? This is -3, 7. Is that 7? No, yeah, -3, 7. We said that one is about -3 and 5, 6.9? No. Okay. -3, I'm going to call it 5.9. Right, this is -3, 1. This one looks like it's about -3, -3.9. And then the last, -3, -5. So that's the hardest kind of problem. You got to complete the square. And then after that, you're going to do what you did on the last one. And the last concept here is this thing I've called eccentricity. Eccentricity in an ellipse is trying to tell you, is this an ellipse that's just a little bit longer in one direction than the other, or is it way longer in one direction than the other, right? So the definition of eccentricity is the c divided by a. Remember, c is telling you what's the distance from the center to the focus. A is telling you the distance from the center to the vertex. If that is really, really small, that means the foci are really close to the center, and this is almost like a circle, right? If the C is very big relative to the A, then this number becomes that becomes closer and closer to 1, and it's longer. It's much longer relative to how much it is in the other direction. So, you could never have an eccentricity of 1. There's no way that the C can equal the A. C is always just a little bit inside. So eccentricity is something in between 0. If it was 0, you'd have a circle, and 1. Now, as they say up here, I mean, that's one of the things that made it really hard when they were first just looking at the planets and the orbits of the planets, is that some of the eccentricities are so small, they thought it was a circle. And at first they were using, let's use all the geometry of a circle to describe these things. And it wasn't quite right. I mean, if you look at the Earth's orbit around the sun, the sun is sitting at one focus, right? And it's very, very close to the center. There isn't anything at the other focus. And, it looks like it's a circle for all practical purposes. It looks like a circle. So this E is C over A on any of these things that we just did that asked for eccentricity, which I think started with that one. If you've already calculated the C and the A, you just divide, right? E equals, in this case, I'll put C over A, which is 6 over 8. And usually that's a decimal, 0.75. Right, the next one, C is 2, and the A was 4. 1/2, 0.5. Right, the next one, the C was about 4.9. And the A we figured out was 6. So you turn that into a decimal. And these are eccentricities of the planets going around the sun. You can see the Earth, right? This is the C divided by A, like a 0.0167. I mean, C is very small in comparison to the distance to the outside of the orbit. So it means that the foci are really close to the center. It's almost a circle. You know, which one has the most elongated shape to it? Mercury, 0.2. You know, it's like 1/5. And the rest of them are pretty small. Is Earth the smallest? Now let's see. That's smaller. That looks like Venus is the smallest. It's got the most circular orbit. And Mercury has got the most elongated orbit. So that's what eccentricity means in an ellipse. And that's it. Like I said, these first 4 are matching graphs like we did on the first. And then these problems are 1-for-1, like the problems we just did in the homework or on the screen here.